What's up guys, it's CodingBoy56, back at it with another video. Today we're going to talk about how to make your very own distance control program. Let's jump into it. So I bet a lot of you guys are wondering right now, what exactly do I mean when I say distance control Myblock? And the answer to that is there's a lot of times on the FL table where you won't be able to use a line for your light sensor to detect, and then for you to line square or line follow, there's no wall for your ultrasonic or even touch sensor to detect. And in those situations, what most teams do is that they use their motor encoders, which is of course the right approach, but it can be done more accurately. See, what most teams do is they have the robot start in a certain position, and then they will move their robot until their desired location, and then using the encoder, it will measure how many degrees the robot has turned its wheel. And the problem with that is there's wheel slipping, the fact that one wheel might be moving more than the other, and then you don't know which wheel to measure. There's a bunch of problems with that, and to just simplify the process, I've created this little Myblock to be much more accurate, because fine-tuning those values is quite honestly a pain. So what this Myblock does is that you simply measure with a ruler or whatever the distance you want the robot to move. Let's say it's 30 centimeters. Then you want to take this number, do some math with it, and then convert it into the amount of degrees you want the wheel to move. And the robot has encoders, the motors have encoders, which is perfect for the situation. So without further ado, this is me explaining it on the whiteboard. So how are we going to approach this problem of converting centimeters from the Myblock into degrees? Well, let's think of the total centimeters that needs to be completed by the robot as a horizontal line. 30 centimeters. Let's say we want the robot to travel 30 centimeters. Well, the available information we do have is the diameter of the wheel. So we can use this information to find out the circumference of the wheel. And that's pretty useful because each rotation of the wheel, it'll take the robot that much further along this track. So I know for a fact that for my robot, the diameter is 3 centimeters. And to get the circumference, all we need to do is multiply that value by pi, which is 3.1415. Usually, you only need 2 digits after the decimal, but you can put more if you like. It's not really going to make that big of a difference. So that is equal to 9.4 centimeters. So every time the robot turns its wheel, it travels 9.4 centimeters. So all we need to do is divide the total distance that we want the robot to travel over by the circumference. And then we can find out how many rotations the robot needs to perform. But here's the problem with that. We still forgot one last thing. Most people use degrees instead of rotations, at least at FLL competitions. And the reason for that is there's a much higher resolution. You have 360 degrees in a rotation, so you have 360 times the resolution. So in order to get the result for degrees, we need to multiply this entire thing by 360. So we need to find one master formula, if you will. And that is the distance that we want it to elapse. In this case, we said that would be 30 centimeters. And then we need to divide this by the circumference, which is broken up into the diameter of the wheel times pi. And then after you got this whole thing, you put that in brackets or parentheses if you like that better, and then you multiply that by 360
oh, whoops, 360. And that'll tell you how many degrees you want how many degrees you want the robot's wheel to turn, well, both of them, to achieve this distance here. Now all you have to do is put that into the Myblock, and we're golden. Now let's put it in the programming.
So here's the program. It is the Myblock, of course, and here are the 4 different parameters. There is distance, which is plugged into the math block. It is 30 centimeters, like we said in the example. Here's the wheel diameter. A quick note about that: if you're using wheels instead of tracks, which is pretty much always the case in FLL use, they are written on the actual hub of the wheel, so you can see the measurement, but please note that it is written in millimeters, so you have to multiply that by, you have to divide that by 10 to get it in centimeters here. And then we have speed over here, which is, it just works exactly like how a real move steering block would work, which we have here, and it's being plugged directly into there, so nothing's being changed. And same goes for steering, so that's also being plugged right into the move steering block. So there's a bunch of math happening here, and that's pretty much exactly what we described on the whiteboard. So it's just taking C, which in this case is the distance. I'm just going to pull that out there so you can see. And it's dividing that by A times B. So that's pi times the diameter. So it's dividing the distance that you want to travel by the circumference, and then it is multiplying that by 360 to give it to you in degrees. And the result of all of that is being popped into the distance that you want the wheel to travel. So it's pretty simple, and that's how the block works. Let's see it in action.
It's going to go from there to there. That's about 30 centimeters on the meter stick. William, press it. Got it? Yep. There's the edges of the robot. And pretty perfect. It's exactly the line, the outrigger at least. And you can try with any distance.
Hope you guys learned something from that video. And if you enjoyed it, remember to hit the like button. If you feel like I earned your subscription, subscribe. See you in the next video. Bye now.